Hi Lizzie, and thanks for the question. The trick to these problems is manipulating the angles into something that we recognize. For example, 5 pi over 3 and 17 pi over 6 are not exactly angles we see often, but pi over 3, pi over 6, pi, 2 pi are. The question is, how can we make 5 pi over 3 look more familiar? In this case, let's try rewriting 5 pi over 3 as 6 pi over 3 minus pi over 3. So we have the cosine of 5 pi over 3, and I'm suggesting rewriting that as the cosine of 6 pi over 3 minus pi over 3. Now this is completely legal inside of the parentheses. And what's excellent about this is this simplifies down to the cosine of 2 pi minus pi over 3. And we know the values of sine and cosine for 2 pi and pi over 3. And that's going to come in handy because now we're going to use our difference formula that you see up here in the top right. So in this case, let's call 2 pi A and pi over 3 b in our formula. That will give us the cosine of A, which is 2 pi, times the cosine of B, which is pi over 3, plus the sine of A, which again is 2 pi, and multiply that by the sine of B, which is pi over 3. Like I said, we know all the values of these trig functions. So cosine of 2 pi is 1 times cosine of pi over 3 by our right triangle up here is the adjacent over the hypotenuse, which is 1/2, plus sine of 2 pi, which is 0, times sine of pi over 3, which is opposite over hypotenuse, which gives us root 3 over 2. Simplify, you have 1 times 1/2, which is 1/2, and 0 times anything is root 3 over 2. Is 0, sorry. That gives us 1/2 as our answer. Now, if you go down to number 3, you have something very similar. You have 17 pi over 6 as your angle, though. So take a look and see if you can make that work if you change 17 pi over 6 into 18 pi over 6 minus pi over 6. And let me know what you get. Thanks for the question. Can't wait for the next one.